Okay, so we're doing more about circle trig today. We'll review a little stuff we did yesterday, but I'm going to start right off with new stuff. So take a look at this. Do you get that this is a triangle within a circle? You are going to draw lots of these over the next several months because a lot of trig boils down to triangles. Even in calc, we just have them do the reference triangle. That's what they keep on saying over and over again when they get to the hard trig stuff. Okay, so you got to learn to be able to draw these triangles accurately. And they always come down to, well, I shouldn't say always. Many times they come down to 30, 60, 90 or 45, 45, 90 triangles. So if you got those memorized, you know, the 1, 2 square root of 3 thing or the 1, 1 square root of 2 thing, then you'll be in good shape. All right, so this one, I took the time to set it up really nice with, you know, perfect straight lines and everything to show you, and I want you to copy this down. Copy exactly what you see on the board here. Doesn't have to be the colors, don't worry about that. But to show you how you get some of these basic relationships in circle trig. So copy this down. Now, the first thing I'd have you label is this right here because the angle we use is always the central angle. And so that would be the one. That's the one that's, let's see, theta. And how do I get the little pointer off of there? Good. Would you agree that this distance going across right here is x? It's the x direction, right? X goes that way. All right. How about this distance up and down right here? Take a wild guess what I'm going to call that. Y. And if this is truly the unit circle, then this would be a 1 right here. But I'm going to call it r for the radius because it doesn't even have to always be 1. It can be, that radius could be other things. I mean, it won't be the unit circle, but I could call the radius 2 or 3 or 5 or whatever. All right, so notice I've got a right triangle here that's touching on the edge of that circle. Okay, so then this point right here, it's not that complicated. That's the point what comma what? The x comma the y. It's the over and the up. X comma y, right? Okay, now here are some leaps that you can start to make. You know what sine is defined as, right? Opposite over hypotenuse. And so what is sine of theta? It's the opposite over the hypotenuse, and in this case that's y over r. And what is r? R is the radius. What if we were in the unit circle? What would y be? And then it would just be y over 1. And then it would mean that the sine is the y. That was a weird thing for me the first time I heard that. That the y distance, the height of this thing, with that spot right there, that is the sine of that angle. It seems like it shouldn't be. It seems like it should just be a side. But if it is a side, it's this side. But if this is a radius of 1 right here, then it would just be y. All right, you may not understand how big of a deal that is until later. Cosine of theta. It's cosine. Adjacent over hypotenuse, which would be x over r. And if r happened to be 1, do you get how that'd be handy? And it would just be x over 1, which is just x. All right, and the last one is tangent of theta. And tangent is opposite over adjacent, so that would be y over x. Notice it doesn't even have the radius in it because tangent doesn't have the hypotenuse in it. All right, so what does all this mean? This means that if I gave you a point like 2, 3, that would mean that this was 2 and this was 3, and then use your big brain and figure out what r would have to be. 2 squared is 4, 3 squared is 9, square root of 13. So therefore, what's the sine? You look and find out whatever the y was, and that was 3, over the radius, and that was square root of 13. Now somebody might be saying, well, can't I just get that by saying sine of theta is 3 over opposite over hypotenuse, 3 over root 13. Yeah, you could do that. But just let me show you what would happen if this was the unit circle. If this is the unit circle, then that means that this is really 1. That means that this is really 1, which means I don't even need it down there because dividing by 1 doesn't do anything. Same as that. So then if it's in the unit circle, then whatever x and y are what sine and cosine are. Sine is the y. All right, so if I was actually going to have this radius be 1, and let's say we were going for about a 45-degree angle, do you get that this would be 1 over the square root of 2? And this would be 1 over the square root of 2? Then if I did the sine, the x is 1 over the square root of 2, also known as, do you remember me telling you that we were going to probably be rationalizing that denominator by multiplying by root 2 over root 2? And so it's really equal to root 2 over 2. And then the y of it is the same exact thing because it's the same exact thing. Root 2 over 2. So now sine is the y, which is this. So sine of this triangle, or this angle, is equal to that. Cosine is equal to that. And the tangent is the y over the x. This divided by this. And if it's the same exact thing, it would be equal to 1. All right. So I know I went over some of your heads right there, and that's okay. I'm going to come back to that. This. Yesterday, I tried to pound into your head how you could remember these numbers. The first one was 30 degrees, and that was pi over what? Pi over 6, or 1/6 pi. If I was going to count it out, I'd rather say 1/6 pi, because then I can say 2/6 pi, 3/6 pi. Remember that? So this is 4/6, 5/6, 6/6. What's this one? 7/6 pi. Sorry, 7/6 pi. 8/6, 9/6, 10/6. This would be like 11/6 pi. 11/6 pi. Okay. And then how about the other ones? These guys. What does that start at? Pi over 4, or 1/4 pi, 2/4 pi, 3/4 pi. All right, just wanted to remind you that. And 30, 60, 90s. You got to have these down. The smallest side in this is what? No, the smallest side, 1, and it's across from the 30. The medium size one is the one that's 60, and the one that's biggest is across from the 90, of course, and that would be the 2. And what's this guy? Square root of 3. And what are these? 1, 1, and they're across from 45s, yes. And what's the last one? Square root of 2. You got to be solid on all that. And when you put all that together, you get something very special. In fact, it's so special. I'm going to talk to you about it for a second here with a little bit of musical background. So what you're about to see is a combination of everything that I've just talked about with 30, 60, 90s, 45, 45, 90s, and all the trig that goes with it. It'll have things like the pi over 2 and the pi over 4 and the 2 pi over 6 and all that stuff all put together in one spot that answers like a billion trig questions. This diagram alone, if you were able to memorize it, would answer about half of the questions for the rest of this year. Behold, I give you the unit circle in all of its glory. Now, there are so many things going on in this that show you trig. Just bask in its glory for just a moment. Some classes have you memorize every part of, yes. Some classes have you memorize this whole thing. I'm not going to ask you to do that. You can if you want to, because it will answer lots of your questions for this year. But let me just kind of show you what's going on in here. Do you get what this 1, 2, 3, and 4 are? That's pretty simple. What are they? The quadrants. Get how this is really dividing up, you know, the x and the y, and those are just the quadrants. Okay, so what else is going on here? Well, it's all of those things like 2 pi and 3 pi over 2, and it's got all of those different ways to say these angles. All of these. Okay, now, just a second ago, I showed you that if this was the unit circle, that the radius would be 1 and some cool things would happen. Do you remember that I said that sine would be y? It would be y over 1, which in this case, since the radius is 1, how do I know that? Because I can look at these spots like right there. 0, 1 implies that it's 1. That sine is the y. Watch what that means then. Some people are not doing math. Come back. That means put that away. Thank you. All right. This is the y. That means the sine of pi over 6, also known as 30, is 1/2. Do you see how it's got answers to trig questions up there? It's got the answer to what is the sine of 30 degrees. It is the y of this, which is 1/2. What's the sine of 45 then? Or 2 over 2. That's just the repaired version of 1 over the square root of 2, which is the numbers that came from the 30, 60, 90 triangle, right? Okay, so the y is the sine, right? So what's this? That's the sine of what? 60. Sine of 60 is the square root of 3 over 2. The sine is the y, so that's this. All of a sudden, we can do it without even having a triangle, because up to here we can make a triangle, right? What kind of triangle is that? A 30, 60, 90. What kind of triangle is that? A 30, 60, 90, just written a different way. What kind of triangle is this one? A 45, 45, 90 triangle. Pause. Okay, so there's all kinds of triangles in this, but how, I can't make a triangle when it goes to 90 degrees. Do you get that? How am I going to make a triangle out of that? It's a straight line. I can't make a triangle with a central angle. There won't be any angle there. Okay, so I can't have a triangle for that. So then I've got to use this whole idea of the unit circle. Because what is the sine? The sine is the y. What is y? Y is 1 right there. What do you think the sine of 90 degrees is? It's 1. All right, so that's where this kind of all fits together. Now, here's another pattern that's going on in this. It's really cool. Sine is the y's, right? The sine of 0 is 0. The sine of 30 degrees is 1/2. It went up from 0 to 1/2. Then it goes up to this, which is a little more than 1/2, a little more than 1/2, and then it gets to be 1 whole. You see how it went from 0 up to 1? Guess what happens when we graph sine? It goes from 0 up to 1. And then do you remember how this thing cycles? Where does it go from there? It goes back down to 0. Watch it go back down to 0. It's the y of this, right? That's a little more than 1/2. That's a little more than 1/2. Or sorry, a little less than 1/2. This, a little more than 1/2. Now it goes to 1/2, and now it goes to 0. See? This is what makes those waves. Then it goes to the negatives. It goes down to -1/2. See, it's because it's going down like this. And then it goes to negative this and negative that, and then it's -1. That's the lowest spot it reaches. When sine gets to the bottom of its cycle, it's at -1. and then it comes back up to 0. It comes back up to 0 again. It makes those waves. In fact, got a nice picture of that here. So the red one is like sine. Cosine makes waves that are exactly the same except shifted over. Let me prove that to you. These are called sinusoidals, which means that they're all based on sine. So cosine is just a fixed, changed version of sine. Watch. I just took the cosine graph there. That's the blue one. You know where it came from? Sine. It's the exact same thing as sine. Just got to shift it over. Okay, so which one came first, the chicken or the egg? So there was an egg just sitting somewhere, and all of a sudden this chicken popped out of it? So if it started as a chicken, well, anyway. Okay, so which one came first, sine or cosine? Sine. Because the whole category is called sinusoidals. They figured out this wave, the sine wave, and if you take the sine wave, you can easily make cosine out of it. But the sine wave is the thing that you can graph like, here, if I put that on top of sine now. The sine wave is the thing you can like graph, let me think. Sound waves. You can graph light waves using sine. Like they go up and down like this, right? And so you can squish these, you can stretch them out to be longer or skinnier, because you know why different light or different colors appear to be different colors? Different wavelengths. This is like a wave. All right, so anyway, this sine stuff is really powerful because this is one of the best things that scientists have ever found to replicate nature with is the sine wave. That periodic going up and down. Tides. It's a lot like a tide. Tides go up and down. We don't live on the coast, so you'd understand it better if we did, but it's just a constant cycle of you're either at the high tide or the low tide or somewhere in between. And, you know, a couple hours later, then you've all of a sudden got to the high tide, and then it just cycles around to the low tide. Some tides are so insane, some harbors go up and down 20 feet of ocean. Like they're empty at low tide. All the water flows out. There's like no water left in the whole harbor. And then when high tide comes back in, the water rushes back in, boats all start floating again. Isn't that crazy? Some tides are as little as like a foot difference. But other tides are, again, just massive. Like the water rushes out of these bays, like torrents of water. Just, it's actually very dangerous if you're trying to swim in it. So anyway, these sine and cosine can replicate all of those things, so that's pretty cool. All right, so if you know what those waves look like, you can answer some different questions then. Like if I say sine of pi that over 2, that's the same as pi of sine of 90. Yes, your calculator can answer it, and it's 1. And how could I know that from looking at this chart? Well, the red one is sine. I go to pi over 2. I go up here, and there's the answer. It's at its peak. The highest sine ever goes? 1. Sine of 90 also could have gotten off of this circle. 90's right here. Sine is the y. It's also 1. You can do it either way. All right. But now you can think of it differently. Do you get that you can get the same answer here or here? At pi over 2? Or 5 pi over 2? Do you get that at 0, sine is 0? And at 2 pi, sine is also 0? Do you get that? It started at 0, it touched 0 in between, and ended up at 0. So if I go 2 pi, I get the same exact answer as if I would have done it at 0. Doesn't that make sense? Because on the circle, 0 and 2 pi are in the exact same place. Just like 0 and 360 are in the exact same place. You get that? It's like going around an extra whole time here is like going out on this chart farther. Eventually, if I go far enough, I'll get to the same answer I had in the first place. If I go all the way around the circle once, it's like going from here to here. That distance, 2 pi. All right. So if I do pi over 2 plus pi over 2, do you get that that's not pi over 4? That's a half a pi plus a half a pi. What's that going to be? 1 whole pi. Sine of pi. Well, and I just go find sine of pi. Here's pi. I follow it up. It's 0. How could I have known what sine of pi was from this big picture? Here's pi. What's sine? Sine's the y part. It's 0. 2 different ways you could have got it.
What's the x part?
Cosine. So yes, this is sine. This is cosine of sine of theta, cosine of theta. And tangent is not shown here, but tangent is the y over the x. So in this case, it would be 0 over -1. What's 0 over anything? 0. So the tangent of pi is 0. All right. There's a lot to understand here, but let's just, oh, one more thing on this. If I add 2 pi, do you get that that's like adding 360? If I go back to my circle, do you get that adding 360 would make me go all the way around the circle and back to the same spot I was at? So do you get that that's kind of useless, that you don't even need to do that? I'm giving you important things that you're going to need to know again in the tests. So, you know, if you're understanding it, totally cool. But if you're taking notes, you'll remember it more. But all right, if I'm crossing off this 2 pi, in other words, if I add 2 pi to my answer, I'll get the same answer I had before. So I may as well not even do it. I can just go back to what is sine of pi over 2, because whatever that is, that's my answer. If I add 2 pi, I'm still going to get the same answer. If I added another 2 pi, I'd still get the same answer. I can cross that off. That's useless. That's like going all the way around the circle the whole time again. I'm still at the same spot I was at. So whatever the sine of pi over 2 is, which we figured out was 1, that's the answer. The answer to this is 1, even if I add 2 pi to it. What if I add 100 pi's? That's 50 sets of 2 pi. So again, kind of useless. It's like going around the circle again. Get the same answer as I would have had the first time. So the answer to this is just 1. Yes? Then you'd have to go see how many sets of 2 pi was it. 2 sets of 2 pi would be 4 pi. And then you add just pi to it. So if you added what you said, which was not an even number of pi's, you're right, then it won't just cancel. But whatever's left over, that's how far you actually move over. That'd be back to like this one, where I had pi over 2 plus pi over 2. That one actually did change my answer, because it was actually equal to pi, or half a pi plus a half a pi was 1 whole pi. So then I needed to figure out what sine of pi is. Yeah, you have to do it if it isn't a set of 2. If it's a set of 2 pi's, though, you can just cross it off. It's like it didn't even happen. So I guess what you're asking me is, like, this one will cross off. What if I did sine of pi over 2 plus some extra, like 2 pi plus maybe a little bit more, like 3 pi? Say I had 3 pi here. Then I would take off the 2 pi part, because that doesn't do anything. Going around the whole circle one more time won't do anything. So 2 pi away from that would leave me left with just a pi. What's half a pi plus a whole pi? 1.5 pi's. Another way to say that is 3 pi over 2. Does that sound like something on the unit circle? Yep. Or here's 3 pi over 2 right here. Answer's -1. All right, so yeah, you can, if it's not a set of 2 pi's, you can't just throw it away. You add the leftovers together, you get that, you'd figure out sine of 3 pi over 2 then. All right, so back to studying triangles. I'm telling you, like half the questions in this class will come down to a triangle. In fact, more than half. Between now and the end of the year, half the time at least, it's going to be a triangle. So you need to get good at sketching pictures of triangles. So I don't want to do all of these right now. Just do tangent of 30. Would you draw me that picture? You can't really draw me tangent, but you can draw me a 30-degree angle and then see what the picture looks like. Now get used to making your pictures in the unit circle. So start from now on, I want you to make a circle with a big cross through the middle of it like this for your triangles. Yes, sir.
So are you suggesting that it would be good practice if you're a
It would be very neat, but you don't really have to have your triangles be perfect. Like, for instance, if I draw this with a 30-degree angle and it's off and it's really only 25 degrees, nobody's ever going to know the difference. So it's okay. Of course, that'd be the best, but it would take extra time. The question is whether it'd be worth it. Okay, so if this is a 30, then I know the rest. I know if that's a 30, this is a 60, and this is a 90. And then I know my ratios are 1, 2, and the square root of 3. Now, do you get that I just did that based on the numbers I used to know, 1, 2, square root of 3? But do you get that that circle that I have there is not the unit circle then? Because its radius isn't really 1. What's this guy's radius? So really then, if you wanted to know exactly what to put, you don't have to do this, but I'm just letting you think about this. If I divided everything by 2, then I'd end up with the same numbers you saw on that giant unit circle that I said had everything on it. Once again, we've got our 1/2, we've got our root 3 over 2 as our x and our y. The reason I divided by 2 here is because this had a radius of 2 and I wanted to get it down to be a radius of 1. So I divided by whatever the radius was. So if the radius had been 5, I could have divided everything by 5. Yes? If I multiplied everything by 2, then I'd have a radius of 4. Does that help me? The unit circle on the outside. Okay, so what you're asking is, this tangent of 30, is that related to the unit circle on the outside? Absolutely. Let me show you where tangent of 30 would be. Remember, here's the 30. Remember how I said tangent is the y over the x? Does that ring a bell? If the tangent's the y over the x, look at the 30 there. Sorry, I'm a little OCD at the moment. Okay. I'd take, here's the tangent, 30. I'd take the y over the x. I'd take 1/2 over root 3 over 2, which if you know how to handle fractions and fractions is 1/2 times 2 over root 3. Do you get how I flipped that over and multiplied? Cancel. The answer is 1 over root 3. Now, could I do that with a triangle? Absolutely. You can replace all that stuff on that big honking circle with a triangle, and here it is. So if I wanted to do tangent of 30, tangent's opposite over adjacent, 1 over root 3. That's how you do it with a triangle, and I think that's way easier than memorizing that whole giant circle. So I'm not asking to memorize the whole giant circle, but the whole giant circle does have the answer in it. All right. How many of you drew the right triangle, the correct triangle? Okay, good. Yes, ma'am.
If you put the triangle over the y-axis, you do it, and then
If I put the triangle here,
yeah.
then it would still be 1, 2, and the square root of 3, but this would be negative here. Yes. It's a good question. All right, so next one, secant of 45. If I was asking you to draw me a picture for that one, secant of 45, you would not want to try to do secant. What would you rather do? Cosine. Cosine of 45, and then whatever the answer would be, you'd flip it. So I really want to do cosine of 45. So the first thing I do is change it to cosine 45. It's not the same thing, but I gotta like flip it when I'm done. So cosine of 45. Draw me a picture for cosine of 45. I'm telling you, from now on, put a little circle around your x and y axis that you draw. And then make your triangles that way. 45-degree angle. 45. Drop and make the triangle part, the x and the y. And I know these numbers. 1, 1 square root of 2. So now what's cosine of that? Cosine, ka, adjacent over hypotenuse, 1 over square root of 2. Is that the answer though? No, because I got to do what? Flip it, because I really wanted secant. So I flip it, and my final answer to the question is flip the 1 over root 2, and it's just root 2 over 1, or root 2. Notice I did not grab a calculator for any of this stuff. So on this part of the test, you're not going to have a calculator. You're going to have to draw the triangles. And they're almost always going to come down to the 30, 60, 90, or the 45, 45, 90. Yes, ma'am. If I don't want the radius to be 0, but I do want the radius to be 1 sometimes. If I want the radius to be 1, then I would divide everything by root 2, right? Because that makes the radius 1. Divide by root 2, divide by root 2, and notice that ends up being 1 over root 2. Remember how they do that on the unit circle? They actually do the root 2 over root 2 thing, and then you get root 2 over 2. That's something on the unit circle. You'll see it over and over again. And then this other side is identical. Root 2 over 2. There's my two sides now. And if this is a 1. So then, what's the answer for secant of 45? Well, secant, instead, I would really want to do cosine. Cosine is adjacent over hypotenuse. That's this over this. And I got to flip it then. That's how I get back to this. Okay. I got a little confused at the end there, but I don't think that one matters that much. Let's move on to the next thing. Sine of 300. Okay. Draw me a picture for that. You got to get good at these pictures. You got to be careful with your negatives, too. You see my little notes there off to myself on the side? It says, watch your negs. Because it's really easy to forget. If you draw the triangle in the second or third or fourth quadrant, you're going to have some negatives involved. Do you get that a 300-degree angle is like not 360, it's 60 less than that. So it's going to be kind of like that. That's the 300 part. The part I really care about is the leftover part, which is the 60. Then I draw my little triangle up like this. How many of you had your triangle in the right spot? Raise your hand if you did. Okay, good. Now let's make sure you make the sides the right lengths. The 60 and the 30 and the whole thing, that's a 1, 2, square root of 3. And now be careful. Which ones are negative? Is the 1 negative? No. Is the square root of 3 negative? Yes, it is. And your radius will never be negative. Now that you got that labeled right, it'll be easy. Sine. Sine of 300 is the same as sine of 60. I showed you that yesterday. You could have done either one. So I'm going to now use the 60. So sine of 60 is opposite over hypotenuse. Opposite is negative root 3 over hypotenuse is 1. There's my answer. Did I? What? Oh, I did use the wrong hypotenuse, didn't I? Okay, so I'm going to try that again. Sine is opposite over hypotenuse. Ugh. Opposite is this, right? Hypotenuse is this. Sorry about that. Negative root 3 over 2. Sorry about that. There we go. All right. This next one, see if you can sketch this next one correctly. It's the hardest one. Cosine of negative 390. Remember, negative degrees start at the same spot here, but then you rotate around the opposite way. You rotate around this way. Okay? So go to the cosine of negative 390. And then draw me the little triangle that goes with it, and then you'll be able to find the answer easy peasy. Once you've got the triangle, you're almost done. Page is this where you put your angle. Okay, I'm going to check and see if you should have put it there. If I go around 360, do you get that that would be going around 360 the normal way? So then let's go around to do 360 the negative way. Do you get how that would be going around 360? Yep. Oh, you weren't doing that one? I was doing this one. Okay, it's negative 390. Makes a difference, doesn't it? Okay. So now I did negative 360. Now I'm going to do negative 390. I got to go how much farther? 30 degrees farther. So then it ends up going, and there it is. And that's 30 degrees this time. Once again, oh wait, I put that in the wrong spot. Once again, I've got a triangle. It's a 30, 60, 90. Clean that up. 30, 60, 90, 1, 2, square root of 3. And you use those triangles all the time, don't we? And then final answer, cosine of it. Cosine, ka, adjacent over hypotenuse. That and that. That's actually a negative one. I should have been careful about that. But it didn't happen to matter in this case because cosine is not using that. Cosine is adjacent over hypotenuse. It's root 3 over 2. Raise your hand if you had that one right. Okay, good. Yes?
I like the way Paige did it, but I still got the same answer.
That's only because we didn't use the negative side. You got lucky. If you'd have gone up here, the answer is the same. It's just that we didn't use one of the negative sides. If we had been doing something that used the opposite side, like tangent, or like, let me think, if we would have done any of the other signs except cosine. And that comes back to what's positive where. Do you remember? What's positive here? All students take calc. Notice down here in this quadrant where we were, cosine is positive. Remember that? All of them are positive here. What's positive here? Sine, and then this quadrant, what's positive down there? Tangent. All right. What if we know a point on a ray of the terminal side? You need to piece that through in your head. That's not the terminal side. That's called the what? Initial side. The terminal side has a point on it of 3, 4. Well, I'm just going to go to 3, 4. There's 3. There's 4. 3, 4 is right there. Do you get that that's a point on my terminal side? That's a complicated way of saying it, but you will need to know that. All right, so that's point 3, 4. Do you get how it makes a triangle? Draw the triangle. 3, 4, and then all of a sudden I can figure out that one. It's 5, and then I can figure out all kinds of trig from that. But when they give you this terminology of a point on a ray of the terminal side, they're still telling you to draw a triangle. All right, what if I was going to draw this one with the 1 and the 4? Negative 1, 4. So then I go negative 1 goes over to here, and then up 4 is right there. That's a point on the ray of the terminal side. So whoosh, like this, and then that's my point, and then I can drop this down, and all of a sudden I've got a triangle. And it's 1 and 4, negative 1 exact to be exact. And then this other side, 1 squared is 1, 4 squared is 16, it'd be 17 squared is 17 for that side. And so they could I could answer all kinds of different trig questions about this because I know all the sides of the triangle. Once you get the triangle done, super easy. All right. What if we know one of a radius, which means we know one of the sides, and one angle? Yeah, you can pretty much get anything of any part of the trig just by knowing these two things. Would you please draw me a circle that has that? The angle is 60 and the radius is 5. Then figure out the other sides using trig. The radius is 5 and the angle is 60. Okay, so here's a 60-degree angle, and here's the radius being 5. Well then, if I know that 30, 60, 90 thing, it's 1, 2, and the square root of 3 is the general ratio. But in this case, it's 5 here, which has got to be twice as big as whatever it was here. How long is it here then? 2.5. And then this side is always whatever times the square root of 3. So what's this side here? 2.5 times root 3. I don't need these helper things anymore. I got the real thing. Now I have my three sides. Now I could say, where is this point? That point is at x comma y. X is 2.5. Y is 2.5 root 3. Oh, that's getting messy, but... Okay. Whew. It always comes down to triangles. All of these are triangles. Any one of these wedges that you pick. If I pick that one, I can make a triangle out of it. And it'll be a 30, 60, 90. Or a 45, 45, 90. If I pick this one, that's going to make a 45, 45, 90. This doesn't make a triangle. Why is it important? Because at this spot on the unit circle, it's at 0, comma 1. Do you remember which one's the sine? Sine is y. Sine y. Say it. Sine y. Say it again. Sine y. All right. That'll just help you remember. If sine is y, the other one must be x. What's the other one? Cosine. And tangent is the y over the x. All right, so at this spot, what is the sine of 90? You are not going to be able to draw me a triangle for sine of 90, are you? You can't draw the triangle for that. How am I supposed to draw a triangle right there? I can't. So, what is the sine? Sine of 90? Sine's the y. Answer's 1. Done. What's the cosine of 90? 0. And what's the tangent? If you remember, it's the y over the x. It's easy. What's the y? 1 over the x, which is 0, which is 1 over 0. What's 1 divided by 0? Undefined. And that's exactly what your calculator would say. If you typed in tangent of 90, it would say undefined, or it would say error. Okay? All right, you've learned a lot of stuff. Let's start the first couple problems together on the homework. All right, the homework is from page 381, problems 25 through 48. I'm going to do 25 with you. We don't have much time, so don't bother going to get a book. I will just start the first few problems with you. Problem 25 says, what is the cosine of 120 degrees? Well, you know, I hope, from yesterday, that you don't have to use the 120. You could use the reference angle that goes with it. So you start by drawing yourself a picture and figure out where 120 goes. It's a little past 90. It's like somewhere like around there. Start with that. You need a little sketch. You're going to have a triangle for almost every problem today. Then, if I'm not going to use the 120, I am going to use this. And what is that? It's got to be 60. Because that way it'll add up to 180 total. Okay, so that's 60. And then I drop this down, and now I got a triangle forming. And it's got a 60, so it must be a 30, 60, 90, right? So then this must be 1 and 2 and the square root of 3. And what is the cosine of 60? How can I do that? Just change cosine of 120 to cosine of 160 because they're the same answer. Cosine of 60 is ka, adjacent over hypotenuse. Adjacent is... Oh, thank you. You're right, and that will matter this time. Thank you. Cosine of 60, ka, adjacent over hypotenuse. The adjacent is -1. The hypotenuse is 2. The answer is -1 over 2. The answer is -1/2. And if you took a calculator and you typed in cosine of 60, it would say -1/2. All right. That was the first one, is cosine of 120. The next one, problem 26. It wants you to do tangent of 300. Draw a picture. That'd be 360, so it's not that far. 300 is 60 less than that, right? So there's my start. That's 300 degrees. But I don't really want to use that. I want to use this one right here, which is really 60. And then I drop my little triangle down, like this. There's my triangle. And it's a 30, 60, 90. And that's 1, 2, and the square root of 3. Make the one of them negative. That one's negative. So then tangent is opposite over adjacent. Opposite is negative root 3 over the adjacent is, that's opposite over adjacent. That's, yeah, that's right. That's right. That's right. There we go. Notice no calculator. It's definitely a no calculator part of this test. I don't know if we're going to have no calculators in the whole test, but there's definitely a lot of stuff you can do without a calculator. All right, I want to remind you of one more thing because I'm looking ahead to problem 37, and it says negative 450. And then it asks you, find sine, cosine, and tangent if the value is undefined, write undefined. All right, well, negative 450, that's in here. Negative 360 would be this way. To make it 450, I have to add on 360, 40, 50, 90 more. That's right here. I can't draw a triangle. But Mr. Server, you said you're going to draw triangles a lot. True. But on these, they're called transcendentals. You can't draw a triangle, but you have to know on the unit circle, what is that spot right there? 0, negative 1. What is the sine at that spot? Negative 1. What's the cosine? 0. And what's the tangent? It's the y over the x, negative 1 over 0. Anything over 0 is undefined. So you got my 3 answers right there. Sine is the y, negative 1. Sine of negative 450. Cosine, negative 450. And tangent, negative 450. Cosine of negative 450 was the 0 part. There we go. Okay. That's all I got for you for today.